Hi, I'm Sabir Grewal. I'm a principal with Graker, a firm that focuses on low latency data analytics. We build applications, data analytics applications for our clients. And today we're here to show you a demo of a Flink SQL position calculator. And it's meant to showcase three things: how to build scalable applications in Flink SQL, how Confluent Cloud infrastructure scales, and then we're using sample fixed messages from New York Stock Exchange just to show you a real world example. So this is kind of a brief architecture diagram. On the left hand side, we've got fixed messages coming in. They're sample messages that we received from the New York Stock Exchange. We're converting them into JSON with our test harness, publishing them into Kafka so that the schema is available there. And then we're running a very simple Flink application, and we'll show you how that scales. So let's take a look at our infrastructure. We've got a Kafka cluster. And we've got a Flink workspace. Our Kafka cluster has a couple of topics. One topic to receive the orders, the order acknowledgement topic, and another topic where we'll publish position data. So we'll look at all the transactions, and then we'll segregate them into accounts and symbols, and we'll publish a live position for each symbol for each account. So the cluster is a basic Kafka cluster, and we've actually been running in messages for some time just to build up a little bit of a backlog. So there are several million messages that we've published over the past few minutes. And as we've published those messages, the Kafka cluster has scaled up in size. So we've actually maxed out the size of this small Kafka cluster at 50 eCKUs. We could ask for that soft limit to be increased, but we haven't. And we've got several gigabytes of data now within this cluster, representing several million fixed messages in JSON format. And that JSON format is important because that's what allows us to work with it. Let's go take a look at the stream lineage viewer. That's a really useful tool that Confluent makes available, lets you visualize a pipeline. So on the left-hand side, we have our Kafka producer, and it's publishing to this topic, order acknowledgement topic, which we mentioned earlier. And then we have a Flink SQL statement. We've got a long-running Flink SQL statement that will calculate position on top of these transaction messages and publish it to the positions topic. And if you look here, the position topic, here's a way to visualize the schema within it. It's actually pretty simple. We just want to know what quantity of every security each account has. When we go to the order acknowledgements topic, which is a representation of the fixed message, the schema is more complex. There's a lot more fields and data in here. And it's to show you that we could do more interesting things, but our example here is pretty simple. Though it's a useful one, how do you calculate position when you've got millions of messages coming in, over the course of minutes? And that's what we're trying to do. So it's actually very simple to do in Flink with the SQL API. We've just written a statement that aggregates the position and groups it by symbol and account, and then it'll publish that data. And now that we've been running it for some time, you can see that Flink has actually scaled up as well. We started out with one CKU, and we've a CFU rather, Flink unit, and we've gone up to 2, and you can see how many messages it's processing, and it's processing millions of messages every minute. Let's go take a look at the Flink cluster or the workspace and see how it's done as we've thrown so much data at it. And you can see, the workspace has a maximum of 10 CFUs, and it went up to 2. It really wasn't stressed. And there's a reason for this. We're actually performing a very simple aggregation on this data. And it's really the amount of data that was stressful. Of course, you can produce much, much more complex analytics which would then perhaps change the dynamic and require more Flink resources. But that's a discussion for a different use case, not a simple position keeping use case. So I just want to go back and recap, what we intended to show you during this demo is the ease with which scalable applications can be built in Flink SQL. And the core of this application was built in about a day, including standing up the infrastructure and the test harness. We also wanted to show you how Confluent Cloud, Kafka, and Flink scales. You can see that scaling. You saw it in the Confluent Kafka cluster, which went to 50 CKUs, and you saw it in the Flink cluster as well. And then we wanted to show you how we could use real-world data to build an application that could conceivably be used, as is, to publish positions on a very large stream of data, and it would be it's Kafka plus Flink stream processing equivalent of something like a stored procedure that you might have running in a database today, with the added advantages that it could scale thanks to the parallelism of Kafka and Flink to virtually unlimited size, and also allow you to perform many other analytics on top of this data and scale them alongside this application. Thanks for listening to us and watching this demo. If you wanted to learn more, here's a little slide with some information on how to contact us. You can email us info@graker.com. There's a phone number if you prefer that, and our website is www.graker.com. Thanks again for listening and watching today.